Good afternoon, students. I would like to invite Dr. Arumuga Babu for our guest lecture on distributed generation. Okay, we all know we have installed a lot of renewable energy sources such as solar power plant and small scale wind turbines. So we lesson welfare about the impact of these renewable energy sources. These are known as distributed generation generators. So we need to know the impact of these renewable energy sources on the grid. Okay, so he will explain the concept of distributed generation and the impact of this distribution generation on the grid. Okay, I would, on behalf of PSN College of Engineering Technology, Department of Electrical and Electronics Engineering, I would like to invite Dr. Arumuga Babu for this guest lecture. Thank you. Sir, you can continue, sir.
Okay. Very good, very good. Am I audible now? Pune Shippo? Oh, okay. Okay. Thank you, Punesh, for a good introduction about me. So now we are going to go for a topic on distribution generation. So what are the topics which I am going to cover is a small introduction about distribution generation. I'm going to make a comparison between conventional and modern power system. How does an distribution generation work? The technologies that are incorporated with the distribution generation, impact of the distribution generation and power quality. What are the advantages distribution generation have, disadvantages, and I am going to end with a small conclusion. So first we are going to see a small introduction about distribution generation. A distribution generation is in simple term can be defined as a small scale ranging from 1 kilowatt to 50 megawatts. So normally when we are going for a power station, that will be in a large scale. But when we are coming to a distribution generation, this here it will be in a small scale ranging from 1 kilowatt to 50 megawatts. So it is the range of distribution generation. So another one important difference between conventional power plant and distribution generation is here all the conventional power will be connected at the generation level, but the distribution generation will be connected at the distribution side itself. Okay. This is the main difference. If you're taking the conventional power plant, that will be connected in the generating station. Here we are going to have the distribution generation at the distribution side. Okay. So I am not I can't give assurance that completely we can replace the distribution generations can replace the centralized power systems, but uh, res- it can respond to a particular needs in competitive markets. So if you're taking centralized facilities like fossil fuels, coal, gas, nuclear, large solar power plants or hydropower and have excellent economic values. If you're taking centralized power plants, since it is producing a huge amount of power, this will have excellent economic value. But it has to be transmitted over a long distance. Power is generated in a remote places. If you are taking hydro power plant, it will be generated near a dam or a mountain likewise. So it has to be transmitted over long distance for the consumer side. You have to transmit the power for long distance. So while transmitting for long distance, this will create more electrical losses will take place in the transmission side and the distribution side. Also, if you're taking the centralized power plant like nuclear power plant, thermal power plant, this will have a negatively affect the environment. So environment will be will have affected by this generation because of if you're taking the thermal power plant, the flue gases and carbon monoxide have a negative impact on the environment. So distribution generation uh, allows the collection of energy from many sources and may give lower environmental impacts and improve security of supply. This distribution generation reduces the amount of energy loss in transmitting electricity. So compared to this conventional power plants, distribution power plants are generated in the distribution side itself. So the losses are very less compared to the previous one. The losses are very less. We are going for um, we are going for renewable energy sources. So it will affect the environment very less. So compared to previous one. Distribution generation is also known as on-site generation or decentralized generation. So since it is generated at the on-site itself, where we are going consumer side itself, we call it as on-site generation or decentralized generation. So this is the conventional power system. If you are seeing this diagram, here the power is flowing from the large generating stations to the load center. Okay, so this is having one-way power flow only. So if you are coming to the modern power system, there will be a bidirectional flow of power. So the power will flow from the load center to the it will have a since we are connecting all the generation in the distribution network and the load centers, the power will have a bidirectional flow in modern power system. So in the previous diagram, if you are observing in the previous diagram, there is here there is no one-way power flow is maintained here. Power always flow from the generating station to load. So it is one way only. So second case, here there is a bidirectional power flow. So this is the main comparison between these two. Here we are having different types of distributed generations are shown here. We can have photovoltaic plants or solar power plants, wind power plants, micro turbines, storage, and and reciprocating engines. So distribution generation include biomass-based generators, thermal, solar power and photovoltaic systems, fuel cells, wind turbines, micro turbines, engine generator sets, and storage and control technologies. So distribution generators can be connected in two ways. One is grid connected or independent of the grid. What is grid connected? Grid connected means this will be synchronized with the grid. The power generation will be synchronized with the grid. Independent means that will be directly connected to the load. So if you are taking, for example, if you are having a solar power plant in your for your domestic application, you can generate this electric power from the solar power system which is installed in your home. So when there is no need of power in your house, you can deliver the power to the grid, and by using a bidirectional meter, you can have a tariff based on the power which you are consumed and which you are supplied to the grid. So the challenges that are incorporated with the distributed generation are in terms of reliability, power quality, stability, and safety of power, safety for both consumers and electric supplier. So reliability. If you are going for a solar and solar, wind, etc. So the reliability of so according to the availability of the wind only, you can have a generation. So there is the reliability of this one will be very less. So if you are going for solar power generation also, that power generation will depends upon the uh, intensity of sunlight only. So the technologies that incorporated are cogeneration, solar power, wind power, hydro energy, vehicle to grid, waste to energy. So the first one, we are going to say about cogeneration. So if you are going for a distribution generated sources that are using steam turbines, natural gases, fired fuel cells, micro turbines, or residual engines to turn on generators. In this case, the hot exhaust gas that can be used for water heating or to drive an chiller for cooling, such as air conditioning. So the exhaust gas is used for heating of water or chiller for cooling, such as air conditioning. So so the cogeneration, you can if you're visiting um, sugar power plant, they are producing. They will have a power plant from the waste. By burning the waste from the sugar power plant, they will generate a electricity for their need. In such a case, that here also the flue gases are the waste flue gases are used for heating the water, known as cogeneration. In addition to that, natural gas based schemes, distribution energy projects can be also include other renewable or low carbon fuel, including biofuels, biogas, landfill gas, sewage gas, coal bed methane, same gas, and associated petroleum gases. Solar power. So photovoltaics or solar power is most important. In solar power, we are extracting electrical energy from sun with two technologies. One is solar thermal energy generation and photovoltaic energy generation. In solar thermal, the heat from the sun is extracted, and by producing steam, we are running a hydro power plant by running a small um, thermal power plant. So if you are coming for a photovoltaic, the intensity of the light is converted to electric energy, and that is used here. So it can be installed in a rooftop, um, residential rooftop, buildings. Um, Also, it can. So if you are going for a photovoltaic type DG, it is a variable, non-dispatchable. It is non-dispatchable. but it has no fuel cost. It is not. It can't be dispatchable, but it is. The next one is wind power. Wind turbines can be distributed energy sources, or they can be built at a utility scale. So if you are taking wind power plant, the maintenance and pollution cost of wind turbine is very less, but it is very expensive to the cost for constructing a wind power plant is very high. So the maintenance is very less, low pollution. But what is the main problem in this wind turbine is the cost for constructing a wind power plant is very high. So in wind power plants, we can have two types of wind power plants. So one is vertical type, and another one is horizontal type wind turbines. If you are taking in the vertical type wind turbines, that will be used for small velocity of winds, and that can be used in residential applications also. So this is the vertical type of wind turbines will be as they are used. They can use to produce electricity from wind power with a small wind velocity itself. But when you're taking horizontal type of wind power plant, and that are some large type of wind power plants, they are used uh, they are used to produce bulk electricity. So hydropower. So hydropower can be also called as renewable energy, DG. So normally, not like the conventional hydropower plants, it is a small hydropower plants. We used to call it as micro hydropower plants. Micro hydropower plants. So this can be installed near in a river or a small waterfalls. We can install this type of hydropower plants as DG to produce electricity. The next one is vehicle to grid. Normally, if we are all speaking about electrical vehicles, even though electric vehicles are non-polluting, we have to go for what is the source of electrical energy? It may be a thermal power plant, or that may be a nuclear power plant. So indirectly, even though vehicles are not polluting the environment, but the generation is polluting the environment. So what is the challenge we are having is, even though we are going for electric vehicles, the environment is polluted. So to overcome that, we have to make sure that the electric vehicles should be supplied power from the renewable energy sources. So this can be how it can be done. So we can install solar in electric vehicles. If you are installing solar cells in electric vehicles, that can generate the electricity as a renewable energy source, and it won't consume power from the grid. So what is the main advantages? It is not polluting the environment. So assume a situation here there is no need when the vehicle is not running, it can supply the vehicle power generated from the vehicle can be supplied to the grid. So that is vehicle grid technology. We also call it as B2G technology. That is a new technology that is going to replace that is going to be installed in all electric vehicles in future. So what we are going to, I'm going to say here is, all the electric vehicles should be installed solar cells, and when it is not in use, we can supply electric power to the grid. So waste to energy, we all know we are having plenty of municipality waste. If you are using municipality waste, or if you are using it properly, we can generate electricity from the waste itself. So impact of DG on power quality. So you, what is the main drawback of DG is it will have a plenty of power quality problems like harmonics, sags and swells, and islanding. So what is this sag? Sag means what is sag? Sag is a power quality problem. Sudden drop in voltage, we call it as uh, power quality sag, and swell means sudden increase in voltage. We used to call it as swells. So this will sags and swells will take place for small duration of time. So this is an important power quality problems that will be taking place in while we are going for this type of renewable energy sources. Also harmonics, even harmonics, auto harmonics are all created in a all created when we are going for this type of power plants. Here we are um, while we are using power electronics devices in the here for inverting and rectification, plenty of harmonics will take place. Odd or even harmonics will take place in this in this distribution system. So this is the main drawback of this distribution generation. So islanding. Islanding means what? Um, assume a situation, a grid is isolated or broken. So we can supply here by using this distribution generation. We can supply that grid or line. So this we call it as islanding. So advantages of distribution generation. Convince. So while we are going for distribution generations, the transmission and distribution losses will be reduced. The second advantages, um, we can generate power from waste. The pollution will be less compared to conventional power plants. The distribution power plants will have less pollution. The disadvantages, uh, we need adequate protection in order to accommodate exchange of power. Signaling for dispatch of resources becomes extremely complicated. Dispatch of power will become extremely complicated. Connection and revenue contracts are difficult to establish. Like connection and revenue contracts are difficult to establish. These are all the disadvantages. So conclusion, the distribution generation helps us to reduce the cost of the transmission line and the distribution losses. The second one, distribution generation playing an important role in the field of electricity generation, whereas different issues related to power quality, when distribution generation is integrated with the existing power discussed before, it can be concluded from this discussion that when interconnecting distribution system to the power system and safety. Time for can ask me regarding this presentation.
Dear students, if you're having any doubts, please raise your questions.
Students, if you are having any doubts?
So we are all using these renewable energy sources in our residence. So that are all standalone system. If we need to connect these
Unmute
renewable
and
energy
ask your
sources such as
questions.
solar or small scale wind turbines to the grid means we can say it is on grid solar PV system and all. Okay, so just imagine these things
Yes.
in a large scale. If you are a power producer, you can install a huge solar farm and you can supply to the grid. So this is the concept. What generation? Distributed generation. Okay, so Professor Arumuga Babu has explained that impacts while connecting these distributed generators to the grid. Okay, so uh, particularly the main thing is harmonics, swag, swell, and all. So we got nowadays lot of technologies have been improved to avoid these power electronics devices have been invented to avoid these power harmonics, to increase the power quality. Okay, so in our upcoming seminars, we can discuss about the recent trends in these distributed generations and how can we eliminate these harmonics and improve the power quality. Thank you. Thank you, Dr. Arumuga Babu sir, for your wonderful introduction about these distributed generations. Thank you. Thank you. Thank you.
Listening this seminar.